In the previous course, we have learned about the establishment of network connections and the sending and receiving of messages. In this class, we will implement a data synchronization application. For example, in our shooting game, we hope that every time a player opens the game, he will see his last score. That is, every time a player logs in, he will get the last score from the server. After each shot, the score should be updated to the server. According to the object-oriented thinking, the network module includes clients, servers, and messages. Because messages need to be serialized and deserialized during network transmission. So, let's first write a message serialization interface. Then, write a message class to implement this serialization interface. Add two member variables to this message class. One for the message type, and the other for the message content. Then add the corresponding get method and construction method. And rewrite the serialization and deserialization methods. When communicating over the network, you need to start the server first. So, let's take a look at how to design the server. First, add member variables to the server, which are the messages received and processed by the server. Then in the onStart method, when there is a session connection, call the callback function. Note that the server may receive connection requests from multiple clients at the same time. To prevent blocking and affect the player experience, asynchronous processing is used here. In the callback method, call the method to initialize the score. Send the score information to the client in the method to initialize the score. Note that the score has not been initialized here. Next, we have to consider how to store the player's score on the server. If we only want to save the total score of the player's shooting, we can use the above two methods. The first method can get the stored score from the server, and the second method can modify the score. However, if you want to record the player's 2-point, 3-point, and 5-point scoring hits and total scores, the following two methods are required. That is, the key and value pairs are stored. Since the logic of the client's 2-point, 3-point, and 5-point shots has not yet been implemented, we will leave it for subsequent improvement, so here we will temporarily use the first two methods. In the method to initialize the score, first get the score information saved by the server. Note that the string score passed here is customized by the developer. Then construct the message. Note that the message type string passed when constructing the message here is also customized by the developer. When the client receives the message, it needs to process it according to the different message types. Finally, after converting the message into a string in SYN format, send it to the client through a network session. Then, let's look at the client again. In the onStart method, first connect to the server. After the client successfully connects to the server, execute the callback function. It should be noted here that for some situations with high real-time requirements, it is necessary to create an identity object after the connection is successful. For example, in a multiplayer ball game, Everyone grabs the same ball. This ball needs to be synchronized to the client by the server. In addition, each player needs to see the position of other players on the court in real time. So each player's client needs to synchronize the player's position information to the server. Let's implement the synchronization of scores first, and ignore it for now. Then, when the client receives the message, it needs to call the callback function. In the callback function, parse the message and process the business logic. It is necessary to emphasize here that both the client and the server only accept communication through a unified interface. Usually we put the processing of these callbacks in a singleton. The next step is to find your own update logic. For example, here, I just need to parse the score in the received message and assign it to the variable in game data. Then, when the score changes, the score needs to be synchronized to the server. Let's first find the code that modifies the score after scoring a goal. After a little thought, we found that when the score or hit rate changes, we can add a variable to game data to record it. Then, in the onUpdate method of the client management class, according to the value of this variable, judge whether it is necessary to submit data to the server. When submitting data, just pass the score of this shot. After that, add this score on the server. In the onStart method of the server, add a callback function to receive the message. In this callback function, parse the JSON string to get the message object. According to the type of message, perform corresponding processing. If it is a message to increase the score, get the value to be increased and modify the original saved score value. If you encounter some situations where you need to reduce the original value, such as gold coin consumption, when calling the change currency amount method, set the value of the second parameter to a negative number. Finally, after a goal is scored, when the score changes, change the value of the variable that identifies the score change. Save. Mount the server control script to the corresponding node of the server scene. Save the server game scene. Mount the client control script to the corresponding node of the game main scene. Save the client game scene. Start the game server first. Then start the client. Run. Test and observe whether the game score is 0 at the beginning. After observing the goal, exit the game and re-enter the game. See if the score displayed is the score when the last exit is displayed. After testing, the player enters the game for the first time, the score obtained is 0. That is, when there is no value of this type in the database, it will return 0 by default. After scoring a goal, exit the client and enter again to obtain the player's last score. This means that the data has been successfully stored on the server. Exit the server. Restart the server and restart the client. Test and find that the player still enters the game with the last score. Start the client alone, and the score is 0. Because the data is stored on the server, you can't get the data without connecting to the server. After scoring a shot, exit the client and re-enter the client, and the score is still 0. The reason is that the server is not started. In this way, everyone should have a basic understanding of the storage and call of our data. In fact, in order to reduce the number of interactions, you can also synchronize the score to the server only before the player exits the game. However, there is a disadvantage to doing this. That is, if you want to get the score rankings of all players in real time in the game. It is not an accurate real-time ranking. Therefore, when exiting the game, synchronizing the score to the server and the synchronization of shooting accuracy are left to everyone as homework.